hypothesis testing for the population proportion P using a reverse binomial solution. In this example, a random sample of size 25 was taken. The p-value is 0.65. There were 21 successes in this random sample of 25, and because H1 says P greater than, we're going to work out Px greater than equal to, so that's based on that sign there, 21. It's a 5% significance level, one-tailed test. In the AQA formula book, there is no table for P equals 0.65, so we're going to use a reverse solution. So instead of looking for successes with the probability of 0.65, we can think of it in terms of failure, so 1 minus 0.65 to give us 0.35. If there were 21 successes out of 25 trials, then there were 4 failures. So our new p-value is 0.35, so h0 p equals 0.35. Because we're reversing everything, p greater than 0.65, that greater than now becomes less than. You have to reverse this sign. So based on the less than and our x value here, we're going to work out from the tables px less than or equal to 4. And this is our new binomial table, n equals 25, p equals 0.35. So we're working out px less than or equal to 4. And here's px less than or equal to 4. If we compare that to the probability of the significance level, 0.05, our value is less than 0.05, so we reject h0. There is sufficient evidence to say that p is greater than 0.65. So you'll notice that the final conclusion is in terms of the original hypothesis. Okay, next example, we're starting with a binomial distribution where the random sample was of size 20, p is 0.75, and again this value of p is not in the AQA tables, so we need to use a reverse solution. It's a 10% significance level, it's a two-tailed test, so we're going to split the significance level 5%, 5%, so we're going to work with 0.05. There were 19 successes out of the 20 trials. So this is now the reverse binomial. There were 20 in the random sample. Probability of success 0.75, so probability of failure 0.25. 19 successes, so 1 failure. So h0 and h1 are now based on the p-value of 0.25, the failure probability. So we work out the mean of our new binomial distribution, and this is the reverse binomial distribution. So n times p is equal to 5. Our x value is less than 5, so we're going to work out px less than or equal to 1. So px less than or equal to 1 is 0.0243. This probability is less than 0.05, so we're going to reject h0. And the conclusion here will be in terms of the original hypothesis. So there is sufficient evidence to say that p is not equal to 0.75, or that p has changed from 0.75. So this value here was what we had originally. This is the value that we were originally testing, so our conclusion should be based on this value and not on 0.25.